So my name's Mary De Silva. I'm Head of Population, Environment and Health at the Wellcome Trust. And I'm very pleased to be here today to introduce the launch of the Behaviour-Change project, which is a new award that Wellcome awarded a few months ago. It's our first major award in behaviour-change science, awarded through the science division as opposed to through humanities and social science. So we're very pleased that we've been able to award a significant amount of funding to this really important area. I'm very much looking forward to hearing much more about the project today. So this is a collaborative award, which is an award of up to £4 million for 5 years. And they're really our kind of flagship awards where we want groups of interdisciplinary groups of researchers to answer big questions in a bold way. And as you'll hear tonight, this project really exemplifies that idea for this type of funding. The other reason why I'm really pleased to introduce this award is that it shows the direction in which certainly population health at Wellcome will be hopefully going under my stewardship. And that is with a focus more towards translational impact and really trying to achieve the mission of Wellcome, which is improved health for all. So for population health, we want to change health and improve health and not just generate knowledge and generate papers. And that means funding different kinds of science. It includes funding implementation science, behaviour change science, interdisciplinary teams, large-scale definitive randomised controlled trials, pushing Wellcome towards more of a translational direction than it has been in the past. So I say this publicly, if there are people in the room who have those kind of ideas, please come and talk to us. We are always open. We like to talk to people before they apply for any kind of grant, be that a fellowship, an investigator award, a collaborator award. I'll be in the drinks area after this, so please come and approach me if you have any suggestions or ideas for projects that you want to talk to us about. So really, this is our first exemplar project. I've only been in post for 10 months, and this was the first project that came across my desk where I went, okay, cool, that's the kind of thing we should be doing more of. So I'm really pleased that it's got funded. I'm hoping as time goes on, there'll be more examples of projects like this that I'm able to stand up and say that Wellcome fund. So very much looking forward to hearing all about it. Over to you.
As has been said, this is a collaborative award, and this is a collaboration both across several centres and indeed 2 countries, and also across 3 major disciplines. This evening, we're going to have all the investigators speak. Myself, Susan Mickey, I'm Professor of Health Psychology and Director of the Centre for Behaviour Change at UCL. I'm going to talk about the needs for this and the vision of this project. Robert West from UCL, Professor of Health Psychology and Director of the Tobacco and Alcohol Research Group, will be talking about the preliminary Ontology. Mary Johnston, founder of Health Psychology in the UK from Aberdeen University, will be talking about the scientists working together. We're all aiming to keep to 6 minutes each. I doubt we'll achieve that, but we want to have a lot of time for questions and answers and discussion. So we're going to break the presentations up. After the first question and answer session, Paul McGuinness from Ireland, head of the large research team at IBM, will be speaking on automated data extraction from papers, followed by John Shaw-Taylor, who's head of computer science here at UCL, on machine learning, and James Thomas, who's professor of social research and policy, will be speaking about the querying system for users. And finally, Mike Kelly from Cambridge University, who was head of public health at NICE, will be ending with some comments on the future, and then we'll have, again, another question and answer session and discussion. So, the vision. I should say that this is a very ambitious project, and one of the key things to making this successful is going to be having excellent scientists working on the project. And we're currently advertising for 4 posts, so if any of you in the audience, either yourselves or know people who'd like to apply, please do. So, building the science of behaviour change. As I said, this is extremely ambitious and aims, and I don't say this word lightly, but to revolutionise the ways in which we do 2 things. Firstly, build knowledge and understanding about behaviour change, but also to use that knowledge to answer real-world questions. And the real-world questions are variants of what works, compared with what, how well, with what exposure, with what behaviours, for whom, in what settings, and why. If that's a bit of a mouthful, it will be unpacked later on in the presentation. But whether one's a scientist, a policymaker, a practitioner, many of the questions we have are variants on parts of that overarching question. The method we're going to use to do this is to harness cutting-edge methodologies to build, firstly, an ontology of behaviour change interventions, and that will be outlined in detail later on. Secondly, an artificial intelligence system, including both natural language processing and machine learning. And thirdly, a user interface, including a query system for policies, practitioners, scientists, and all those wanting to answer the kind of questions I've outlined. And as I said, very importantly, this is a collaboration between 3 key sciences in this endeavour: behavioural, computer, and information science. This project would absolutely not be possible without all 3 of those sciences. And indeed, is one of the very exciting things from my point of view to be working closely with scientists who I haven't worked, or scientific disciplines I haven't worked so closely with before. So what's the problem that we're trying to address? We estimate there are over 200 evaluations of behavioural interventions published each day. This is an enormous amount, and more than human beings can possibly make sense of or keep abreast of. The way in which these evaluations are reported when they're published is massively varied. So the same terms may be used for different concepts, the same concept expressed in different terms. Extremely difficult to synthesize or to draw theoretical conclusions about mediation, that is, how these interventions are having their effect, or moderation, i.e., how do they vary across population, across context, across behaviours, etc. And if we can't understand these things, we're not in a position to improve our interventions. And I should have said right at the beginning, but in a way it's the starting point that I think is the reason we're all here, is that changing behaviour is at the heart of solving all of the big problems that we're facing in society, whether it's health, climate change, environmental sustainability, social cohesion, etc. A third issue, a third problem, is context sensitivity. Most of the research that we look at has actually been done in the United States. And when there's somebody in a local authority, for example, taking decisions about what to do for a particular public health problem in their locality, the extent to which that research is relevant to their situation is often very questionable. So much of the literature that's published isn't directly relevant to the specific context in which that knowledge is being used. And fourthly, there's a real need for timeliness. When people want to use evidence, they want to use it to solve problems right now, to make decisions right now, to formulate policies. And research has shown the typical time for study results after they've been published to be included in published systematic reviews is anything from 2.5 to 6.5 years. And I think it was 8 years I was on NICE's Public Health Interventions Advisory Committee, I was acutely aware of that, that by the time we made recommendations for practitioners and policymakers, the recommendations we were making was informed by evidence that was many, many years ago in many different contexts. So these, I'd say, are the four key aspects of the problem that we're addressing. So, what do we need? We need collaboration between behavioural and information scientists with computer science, so that we can efficiently advance our understanding of behaviour and to answer these kind of questions that are coming from politicians, policymakers, practitioners. And we have a 4-year plan. Firstly, to build a behaviour change intervention ontology, which is a way of organising relevant information from research reports. So across that, all the heterogeneity and variability that I've mentioned, bringing it all into a tightly specified, structured ontology. Secondly, develop a natural language processing system to automatically find and extract the information, starting with the use case of smoking cessation. It's going to be very complicated, even just taking the first instance of smoking cessation. But we will build this so that we're not dependent on human beings trawling through at great lengths, only finding a small part of the literature, and then not really being able to synthesize adequately. Thirdly, developing machine learning and reasoning systems that will be able to integrate and extrapolate from that information to generate new knowledge and hypotheses about behaviour change. And this is where I think it gets very exciting, so that there'll be new predictions made that we can then go and test empirically. And fourthly, a user interface that will be able to answer questions about behaviour change interventions and also, importantly, explain its conclusions, how those answers were brought about, with what degree of confidence, etc. So, as I said, this is an extremely ambitious project. When we were interviewed, I was asked, how can you persuade us that you can do all of this in 4 years? And I said, I absolutely can't. But if we get down this route, we'll have made significant advance, even if we don't achieve everything that we set out to do. I also think there's no alternative. I really have, over the last 15 years or so that I've been in this field, I've really come to the conclusion that we really can't make theoretical progress or really significant progress in developing effective behaviour change interventions if we don't have a qualitative step up and, as I said, revolutionise the ways in which we do business. So I feel optimistic, confident and excited about the next 4 years, and I will now hand on to Robert West, who will talk about the preliminary ontology of behaviour change interventions. That is where we're starting from.
So I'm just going to spend a few minutes talking about the sort of knowledge base, the structural starting point for this, which is this preliminary ontology. And Susan has mentioned, you probably all know, or perhaps most of you know what an ontology is. It's a formal data structure that a computer can use to represent information, represent knowledge in terms of a defined set of constructs and their attributes and the relationships between them. And that's the key, because the way that we express ourselves in natural language leaves too much ambiguity for us to be able to use these kinds of automated processes to work with. And as Susan has said, what we're trying to do with this ontology is to answer what you might call as the big question in behaviour change. What works, compared with what, how well, with what degree of exposure, for whom, in what settings, with what behaviours, and why. And what I'm going to do is just unpack that a little bit so that you can see exactly what we're talking about. So when we're saying what, as in what works, we're always talking about an intervention versus a comparator, because whenever we're looking at cause and effect, there's always a counterfactual. And that's really important because, as you will know, if you're ever involved in any intervention studies, without a comparator, you don't know what would have happened otherwise. In any case, there is no otherwise. In a general sense, there's only an otherwise. What else would you have done? So we do placebo-controlled studies, we do studies against usual care, we use studies against brief advice, and so on. So the intervention and comparator are critical. They're at the heart of this. So we need to be able to identify the content of the intervention and the way it's delivered, because both of those will be important. We need to be able to capture exposure, which we can think of in terms of the reach of the intervention. That's to say, to what extent does the intervention actually even get into the same universe as the person? So, for example, if you design an app which only works on an iPhone and people don't have an iPhone, then it's not going to reach people who don't have an iPhone. But then there's also engagement, which is the user-defined, user-driven part of it, which is the extent to which the person or people, the population that you're interested in, are using or engaging with the intervention that you're proposing. The population is absolutely critical in terms of its characteristics. Whose behaviour are we trying to change? There are issues, for example, around are we talking about pregnant people? Are we talking about people with mental health problems? In the case of smoking cessation, for example, how important is it what the level of nicotine dependence is, what their family circumstances are, and so on. So we need to be able to characterize that population in ways that make a difference to the way that the intervention or the effectiveness of the intervention. But we also need to take account of the setting, the culture in which the intervention is being delivered. In a smoking cessation intervention, for example, let's say brief advice for smoking cessation, you're going to have a different effect in a culture where there's never been any, or there's very little tobacco control going on, so that when a GP or a physician or a health professional of some sort says, you know, smoking is really bad for you, I think you should stop smoking, this is what will happen if you don't, it's actually news to that person. Whereas in a culture with a very strong tobacco control climate, then the impact is going to be potentially considerably less. So setting is really important. We want to know how the interventions work, because if we don't do that, we're constantly playing 20 questions with nature, as has been famously put. Because unless we have a theory or a model underpinning the way that an intervention has an effect on something, when we come to a new situation, we have no basis for extrapolating into that new situation. And given the infinite variety of contexts, populations, and ways that interventions are delivered, then we're always going to be having to do yet another study to find out whether something worked or not. And then, of course, finally, but very importantly, we have the behaviour itself. Different behaviours have different characteristics. Some behaviours involve stopping things, and some involve starting things. Some involve areas of dependence or motivational problems. Some involve problems of cognitive capacity. So we need to understand what the behaviours are. So this is the challenge, and you can see why we have decided to focus on a specific use case, primarily smoking cessation. It's an area where there is a very large evidence base. We have good hard outcome measures with biochemically verified abstinence rates, but even then it's going to be pretty challenging. This is the version 1 of the top level of the ontology expressed in diagrammatic form, and I won't go into detail about it. There's plenty of opportunity to study this later if you haven't already seen it. But what it does is it represents what we think are the top level influences that occur within the system. And the reason why effect, which is at the top there, is coming out of the whole of the blue bit of the pyramid, or the iceberg, depending on how you look at it, is because the effect is associated with the whole of that system. The effect is not a property of the intervention, it's not a property of the behaviour, it's not a property of exposure or any of the individual elements within the system. The effect size is a property of the system as a whole. So when we extract information from individual studies, what we'll be doing is collecting all those features together and then associating all those features with an effect size. So that's the key idea. Fortunately for us, there are many examples of ontologies out there, and we're not going to be starting from scratch in creating ontologies. And in fact, we are proposing to draw very heavily on and map what we're doing closely to Cochrane's, what they call PICO ontology, which is for clinical studies. It's not for behaviour change, but it can be adapted for behaviour change and extended. And so PICO stands for what is the patient, the population, or the problem, and then what's the intervention, what's the comparator, and what's the outcome. And I think you can see already from what I've said so far that this captures quite a lot of what we're interested in, but it doesn't capture everything, and it won't capture it in the level of detail or with the kind of constructs that we're interested in. But we propose to work closely with Cochrane to develop that. So that's the beginnings of the ontology, and I'm now going to hand over to Mary, who's going to talk about how we're all going to do this working together as comrades and friends.
So Robert has outlined the complexity of what we're trying to do, and Susan has identified the quantity that we have to deal with, and we want to make it usable. So clearly this is not something that's going to be done by any one discipline, and we're talking now about the collaboration between 3 disciplines. And that collaboration, of course, tremendously exciting, tremendously challenging, but absolutely essential to this project. And I'm going to be describing this diagram, but I'm going to take you through it in pieces. So we're talking about an interaction between 3 sciences, and it's not something that happens once. It's an iteration. It's going to come and go in different phases of the project. So there are 3 sciences: computer science, information science, and behavioural sciences. The behavioural science is going to deal with the ontology of behaviour change, answering the question, how can we organise the evidence in an ontology? Computer science is going to extract and interpret the evidence. What does the evidence show? What does it mean? And finally, information science is going to make this information accessible in real time and at scale. How can we make the information usable? We start with the behaviour change experts who are going to design this ontology, and Robert has taken you through a fair amount of the ontology. The ontology will then be used it will be informed by the scientific literature, but it will also be used to annotate the scientific literature. And that will be the first phase that the behavioural scientists will be involved in. When we come on now to the computer scientists, they will look to see if they can annotate and integrate this scientific literature. What we want to achieve here is a way of extracting the information from the scientific literature without requiring human beings to do it. And so the ontology is going to be used to extract information from the public literature, but organised using the ontology. So you can see that's quite a bit of interchange between the behavioural scientists and the computer scientists, because the behavioural scientists are in effect training the machines, and the machine will learn, and the machine will reason and interpret the evidence. The third part of the collaboration is the information science. When we've extracted the information, interpreted the information, we want to make it usable, and this is a really important part of what we're trying to do. So, given that we're successful in this project, as Susan has outlined, we promise to get as far as we can on this project, we will end up with an interface which you can come to with a query, and you can ask a specific question, and our interface should be able to answer it for you. So you should be able to use any part of the big question. What works for a particular population, for a particular behaviour. And what the interface should be able to give you is effectively a real-time meta-analysis, a real-time summary of the evidence. And if we can achieve that, I think it will be tremendously exciting. Obviously, all of that feeds back into the system. The system interacts, it integrates. We're not talking about a sequence of one discipline does something, then another discipline does something, then another discipline does something. We've got to work with each other all of the time, so that if we get interpretations of the evidence that don't make sense in behavioural science terms, the behavioural science people will be commenting on that. So this is how we expect the collaboration to work. We start with the behaviour change experts designing the ontology. The ontology is applied to literature, and we get a provisionally annotated scientific literature. This is then fed into an AI system which is going to interpret it. automatically annotate it. And at this point, we have the literature organised according to the ontology, and this will be informing the user interface that people can then interrogate. You can see we have an unstructured scientific literature here, which will be fed into this system and also interpreted. And of course, we get new insights, we get an interface that allows us to interpret the evidence. And that interaction is what we're talking about when we talk about the interaction between the disciplines in this project. Thank you.
Let me just start by maybe trying to ground a little bit of what we're doing. People, well, certainly my daughter, when I talked to her about the project, said, isn't this just like a search engine? Can't I just Google questions in behaviour change and I'll get something back? And try it, it's interesting. You get lots of things back, not always what you expect. So I want you to think of this maybe as a set of graduated problems. Internet search is helping you find things by keywords. Okay, it's good for basic information retrieval. We want to get a little bit further. The next level might be to look into the documents and to try and pick out one or two facts in the documents, so to start to summarize the knowledge that's in there. We want to get at least to there. And then the third step would be to say, can I actually start to synthesize things? Because imagine you've been invited to the coolest party in the world. It's the Human Behaviour Change Party. Right? You're all going to be talking about research papers. But the rules of the party are, it's not that exclusive, actually. We're going to double the size of the party every 8 years because there'll be more and more publications. And you're only allowed to talk to 13 people because that's the average number of citations on a health and wellness paper. So that's the kind of circle of connection of one publication. You don't have to be too mathematical to realize that eventually the number of publications goes like this, but the number of connections goes like this. So you've got a basic problem of finding information and then connecting facts together. Okay? So actually you're quite gregarious as a community because mathematicians only cite 3 people. So we really have to help them. Okay? So let me move on quickly because I'm eating into my time. So here's what I thought I'd like. Right? I'd like somebody who can look at not just 1 or 2 documents for me and write a report, but look at pretty much all of the documents in a particular area, who can be my research assistant. I want them to do a few things. I want them to be able to read really fast, right? And I want them to be able to retain facts. Because I don't know about you, but I find as I get older, I forget things that happened 5 years ago. I can't remember things that happened 10 years ago. And so things that I've read, facts that I've accumulated, I don't want to lose them. I want the computer to remember them all. So we have a recall requirement. Then I'd like it to make systematic connections, and this is back to the idea of an ontology. Okay, so that we've got a way of organizing the content of these documents. So we will be doing quite a lot of work to not just look into the documents, find out what the words are. That's kind of natural language processing 101. But we will then be trying to make sense of those words and doing some clever processing to try and connect them back to the formal terms that are in the behavior change ontology that you saw earlier. What's the power of that? That means then that you can start to query consistently over all of the documents that we've summarized by the system. So if you ask one simple question, the system can very quickly look over the hundreds of documents that it's indexed, or the thousands, or the hundreds of thousands. And so what you begin to get is a view across many, many, many sources of information. This is an interesting one. I'll talk a little bit at the end if I have time about the kind of things we're doing right now in other areas related to the general area of health and wellness. But this idea of making an unbiased assessment. What does it mean to state something in an English sentence? Think about how you write things. You know in your head what you want to do, and then you have to turn it into formulaic prose, because that's what the reviewers like to see. And so you lose something. We want to try and get back to making an unbiased assessment of what you were trying to infer when you wrote that sentence down. Okay, by looking at the context of the entire document, by looking at what other people might have written in this particular area, and trying to say, what's a reasonable assumption about what they were trying to say? Okay? And then, of course, no small problem, we want to get it all into a nice compact form in a not too big computer, so that other computers can use it. And so Susan talked a lot about, and Robert and Mary, about open science, about making this accessible and how we want people to use the system. So very much a part of this is to provide interfaces. So as this thing starts to breathe and live and take over, we want people to come along, query the system, and use it to build other things. This is not a closed system that we're building for just us. It's for everybody who's interested in accessing it. Now, what are some of the small and sort of computer science-y type problems? How can I take knowledge that's expressed in different ways by different people in different sources, join it all together and make sense of it? This is really difficult. Sometimes people are verbose, right? Sometimes they're not. Sometimes they write text to make up a certain number of pages for publication. Sometimes they don't. We can find that information is really only in a couple of small places in a publication. And we need to figure out how to denoise all the other stuff that's not really that relevant without losing the real deal. Ambiguity is a really big one. I think we talked for most of our meeting today about uncertainty and how we resolve ambiguity. What did that person really mean? What does that score really mean? What does that confidence interval really mean? Okay, so that we can represent, again, consistently across the knowledge base. And then assign confidence. A couple of people put their hands up, right? So a few people, I presume, have been burned by building overly complex programs that just don't work. They can't run in efficient time. They can't run on reasonable computers. We will have the same problem here, because the kind of key balancing challenge is get all of the richness out, put it into this organizing ontology format, and please don't make it so complex that no computer can actually crunch the numbers in there. So quite a lot of clever engineering will have to go on to make it work. So now I've kind of hopefully sort of set out a few of the challenges that we have. Actually, we're fairly far progressed. Has anybody heard of Jeopardy and Watson and playing games? Okay, so a few people. Good. So essentially, that's a question and answering system that played against humans. Okay. It was able to take a vague question, a vague statement, and find the correct match, if you like, in a knowledge base. So it was about question and answering. We've taken and advanced those kind of techniques and applied them in the health domain. So Medical Recap scans through PubMed papers and allows you to extract risk information about treatments for oncology. So what we can do now is scan through the papers, go into the kind of tabular format. So it's quite detailed work. And when a physician types in a particular treatment regime, we can give them a risk score, so that it allows them to decide whether or not it's a reasonable set of treatments to use in this particular case, all based on natural language processing. Okay, so the same kind of things we'll have to do here. Watson Oncology Advisor takes that a step further. So Watson Oncology Advisor provides a physician with a ranked set of treatments based on all of these kind of multidimensional scoring algorithms. Robert mentioned all of the different modes, all of the different measurements, all of the different features that you might encounter in a document. How do you balance all of those to provide you with ranked, assessed scores? We're already looking at those kind of problems. And the latest one is really cool. It's not out there yet. It's still in the labs. We're teaching machines to debate like humans. Okay? So if you were to think about what that requires, right? You have to be able to assess vague information. You have to be able to take an assertion, and you have to decide whether or not it's just a wild accusation or whether it's based on fact and evidence. And so much the same kind of things as we'll be doing with the human behavior change documentation as we process them. Okay. Now, I'm going to kind of stop here because very quickly I exhaust what you want to do with documents when they're organized in an ontology. You can query them. What happens next is really cool. Right? It's when we start to do some machine learning and some artificial intelligence. And I'm going to hand over next to my colleague and collaborator, John.
So Paul has, I think, really beautifully highlighted the kind of things that are now being achieved with artificial intelligence. And I don't think I can emphasize enough what a revolution is happening in computer science in this area. It's been a dream from the beginning of computer science. Indeed, Lady Lovelace, who was perhaps the first computer scientist in the 19th century and sort of had this vision of how machines could do computation, was thinking that they might emulate the kind of behavior and the kind of intelligence that humans exhibit. Alan Turing picked up that theme in the 1950s and saw this as the great vision of what computer science might achieve. But all of their thinking tended to be focused on what I would call logic-based reasoning. So this was the question of artificial intelligence. Can you produce machines that think like humans? And it's been a dream, as I said, from the beginning of computer science. And all of these attempts have been focused around logical reasoning, or were initially focused around logical reasoning. And to be honest, they pretty much fell flat on their face. And despite, the huge advance in computing, the best that was achieved, I think is fair to say, was the Deep Blue chess-playing system, which was very impressive. But when you looked at it, somehow was uninspiring because it was just a brute force, or in essence, a brute force. Obviously very well engineered and a great deal of expertise in the way that the thing was designed. But at essence, it was a brute force exploration of the game ahead in order to look for the best strategy to beat. So what this project is trying to do is actually to build a bridge between the logic-based, which is at the heart of an ontology, and the soft or machine learning side, which is trying to understand more nuanced, complex data. And Paul has been talking about how a paper may be trying to say the same thing, but saying it in different ways, depending on the emphasis the writer has, or the particular expression style they have. So machine learning is sort of a completely independent track that has been looking at ways of finding patterns in data. And it's based on probabilistic inference and not logical inference. So it's looking for the statistics of particular types of pattern in the data. So an example would be looking for images, for example, and trying to label them as to whether the image contains a bicycle or not, for example. This is just an example of the kind of things that a machine learning system can do. So this task is done by feeding the system examples of images that actually have bicycles and some that don't, and the machine attempts to find the pattern that actually distinguishes those two types of images. And then once that pattern has been found, it can then make predictions correctly on new images that it hasn't seen before and say whether they actually contain a bicycle or not. And there have been very sort of significant advances in this area which are now delivering performance on this type of task that are similar to humans. So in this area of very specific recognition, shall I say, abilities of patterns, the machines were able to match human performance. Now, where I think the very exciting things and the revolution is happening are where these two strands are being combined. And this is what I'm calling ML for AI, or machine learning for artificial intelligence. And I think what the reason and this is the key idea I wanted to convey, the reason that this is somehow made the change that we're seeing in terms of the performance that Paul has alluded to, and I'll mention other examples, is that the logical, if you break a problem down to a logical definition, you actually have denuded it of a lot of information that might be useful in making your inference. So you've effectively thrown the baby out with the bathwater. The richer representations that contain all the extra information, all of the context, are actually essential in order to actually make the logical reasoning or the intelligent reasoning that you're attempting to achieve. And we've seen, as Paul mentioned, remarkable successes with the IBM Watson playing Jeopardy. I'm sure you may have heard of DeepMind, Google DeepMind, that is based in London, and they've now achieved human performance at playing computer games, and even more spectacularly have designed a system that has beat the world champion at Go. Now, Go, you might say, well, that's similar to chess, but the difference is that Go is a game which has an enormous number of choices, and it's absolutely impossible to do a brute force, as I alluded to with the chess playing. Here you actually have to understand patterns in the data, and that combination of patterns with the inference is what delivers the performance. So the intention with this, the use of these technologies, we'd like to bring them to bear on the challenges that the Human Behaviour Change project presents, and both in turning to in learning to populate the ontologies and to improve suggestions for improving their structures, and delivering new intervention ideas and generalizing from the information that we've gleaned from these very many different reports that we've integrated into the system, how a new intervention might be designed for a new context that perhaps has not been reported previously in the literature. So I'll, at this point, hand over to James, who will be talking about the user interface.
I'm going to be responsible for the development of the user interface, and so I'll have a quick plug here that if you know anybody who's a wonderful HTML designer, coder, then we're going to be recruiting soon. And we want to develop this interface. And this interface is actually very important for the project itself as well as for the utilization of the evidence that the project will produce. So one of the things that you'll have heard an awful lot about is the development of this ontology and how it's going to interact or not interact with the artificial intelligence and machine learning reasoning systems. And what we need in order to do this successfully is to get some of that user perspective in there in order to say, well, you know, some of these inferences may make sense, some of them may not make sense. I don't know if you've used some of these new handwriting or newish handwriting tools. I was trying to take some notes over there with a tablet and handwriting. Sometimes it's amazing. It gets my handwriting, which isn't great. Absolutely right. Sometimes you just don't know where it's come from in terms of what it's thinking I'm writing. And we get some of the same kind of things through from a system which is completely unsupervised. We're obviously going to have the behavior change experts' view on this, but that's a relatively small group of people. So one of the things that the user interface is going to enable us to do is to bring into the system a much wider collective of perspectives in order to critique and in order to feed through into the further development of the ontology and the system. We obviously want the system to be widely used as well as the sort of like the user interface that you see. Paul referred to the fact that the data themselves will be published as some kind of machine-readable form so that other people can then develop systems themselves using these. So this isn't just a user interface. The user could be people. The user could be other machines. And one of the things we're going to be doing as part of this section of the work is conducting evaluations. As I've mentioned, I'm interested in systematic reviews. So I'm interested as a systematic reviewer in terms of how can I use the system. So which parts of the systematic review process can be automated and how well? Am I able to replicate a systematic review using this system? Am I able to identify the same pool of studies? Am I able to identify more studies? These are sort of fairly basic questions around how we currently synthesize and how we currently utilize knowledge. But then I think there's some more interesting questions, potentially more interesting questions, about how the use of a system like this transforms the way in which we think about evidence synthesis. What I'm thinking is that we're going to be able to draw on a much a much more in-depth, a much more diffuse, potentially, pool of knowledge to answer some fairly specific questions. And what I'm interested in doing is thinking about, well, okay, so we've got some studies which are not exactly in the area of that I'm interested in, but thanks to the ontology, which is able to describe and identify these relationships, am I able to draw some kind of conclusions from them? Are they able to address some of my research problem? So we've got two evaluations that will I hope, get at two different sort of ways of knowing, two different epistemologies. One is the current way of thinking about evidence synthesis, and one is, well, what does this mean for evidence synthesis in the future? And there's some interesting methodological questions that maybe Mike will pick up on in his little bit here. Someone asked earlier on about users, so I wanted just to mention users. In the proposal, we've kept the users fairly broad, which is our aim is to sort of to test the degree to which different users are able to interact and use the system and want to interact and use the system. Certainly me as a researcher, I want to be able to use the system. We want to develop a user interface that will enable intervention developers, intervention commissioners, for example, to be able to consider and think through the different options for intervention, the possible different consequences of particular different intervention choices. Someone mentioned something about resources and economic and cost-effectiveness analyses. I don't think we'll get as far as cost-effectiveness analyses, partly because it's so context-dependent. But it would be really nice to be able to build in something into the system which is able us at least to consider some of the potential resources that are required for particular intervention options. Again, that's going to have to be a research question in terms of how far we get with that. I'm going to stop there because I know that Mike's going to talk about some further epistemological questions.
This is an extraordinary scientific development in the field of behavioural science for a number of reasons. The first is that this project, I think, once and for all, puts behaviour change onto a properly evidence-based platform. We've come a long way. About 18 years ago, I left the academic life where I was running a school of social science and joined the National Health Service. And one of the things we had to do in those days was to help people find psychological or sociological evidence to help them make interventions work. And basically what they did was went along to their local university, spoke to a friendly psychologist, and whatever that psychologist said was what was implemented. Now, we've come a long way since then. We've been through the notion of an evidence base for public health, research synthesis of evidence, evidence guidelines. We've been through text mining and big data sets. But this, I think, moves us to a new level, in a sense, at a meta level, bringing that information together. We've heard from Susan that the pure volume of the information makes this an absolutely urgent task. By the way, the person who asked about cost effectiveness, one of the reasons that cost effectiveness is so difficult is that the behavioural models upon which economists build their models of cost effectiveness are so poor. And one of the things that we will be able to do, I think, is help the discipline of health economics, public health economics, move forward. The policy problems which involve behaviour, Susan also alluded to at the beginning, are significant. Yet if you look across the panoply of policies being pursued by our government, by government north of the border, across the Irish Sea and across Europe, the degree to which it is evidence-informed about the behaviour change is extremely limited. It is still a matter of picking your theory and putting it into practice. This will be a step towards moving us away from that kind of approach. There remains presently a large gap between knowledge and action that policymakers and politicians take. And again, what we're doing here, I think, provides us with a bridge to close that gap. And perhaps for me, one of the most important things, we might at last begin to supersede the dogmas of common sense in policy making relating to behaviour change, which so run through as a unified stream of policy presently and in the past. What, of course, we need to do is make sense of this mega information. And, you know, when you begin just to reflect upon the sheer volume of stuff involved here, as well as the gap to where the policymakers are, I think you can see that this kind of approach is one that should yield us at least the first important steps. I think it's nothing less than a revolution in the evidence base, on a par with what happened in evidence-based medicine 2.5 decades ago, bringing the kinds of issues which are central to the nature of bringing about large-scale population change to hand. The applications, I think, are very widespread indeed. We hope that this will be a tool of use to policymakers in public health and beyond, providing a platform for properly evidence-based policy interventions. Those bodies charged with making public health recommendations nationally should also find this kind of material, this kind of technique and tools extremely useful. So Public Health England in the UK, in the United States, the Agency for Healthcare Research and Quality, are two bodies with huge appetites for evidence-based information, but struggle making sense of the enormity of the information and data before them. Closer to home, the What Works collaborations could do with a step up, and this will help to provide that, I think. NICE itself, my former employer, I think would find this kind of approach enormously helpful in terms of making sense of the huge amounts of information we've got. And of course, academic colleagues and colleagues in decision-making bodies like local authorities will find a ready library, really, for what's on offer. And of course, the Cochrane and Campbell collaborations, along with information scientists. So what I'm arguing is that this is potentially, at least, a significant, if not paradigm shift, moving the paradigm on a good deal. And I think we should enjoy the celebration as we do so of this important step, and actually to congratulate Wellcome in having the courage to fund something like this, which when we first started talking about it about 4 or 5 years ago, I think, Susan, people thought we were completely crazy. I don't think it's crazy, and I think it's something that, well, at least in 4 years' time, we'll see if my chiliastic kind of predictions are on the button or not. Thank you.